Hello! This is our first video in a series. We're going to be starting chapter 3 today, 3.1, which is all about functions. So go ahead and take out your notes. Title this section 3.1 Functions. Functions is the name of the game. We're going to start out with the definition of a function. A relation that pairs each input in the domain with exactly one output in the range. Is a function. Now, there are many vocabulary words in this definition, so let's kind of break this apart. First thing I notice is the word relation. A relation is a set of ordered pairs. So an ordered pair, it's usually written parentheses, the input, comma, the output. And that's x, comma, y when we graph on a coordinate system. It is alphabetical, so that's convenient. X, comma, y, input, comma, output. That's the first vocabulary word that stands out to me. That pairs each input, we now know those are all the x values, in the domain. Now, domain is another vocabulary word. We're going to make domain red in our notes. So domain is the set of all possible input values. Domain. So domain is just a list of all of those input values. Remember, input goes with x. It's that first number in an ordered pair. With exactly one output. Exactly one output. That looks very specific. That must be important. Exactly one. Exactly one output in the range. Range is also an important vocab word, so let's evaluate that. Range is the set of all possible output values. Range is the set of all possible output values. So remember, y is your output. So it's the set of all of your different y values. That is the range. Once those conditions are met, that constitutes a function. And function is the actual vocab word for this definition, is a function. So let's examine a few relations. There are multiple ways to represent a relation. And we're going to ask ourselves, is the relation, is the set of ordered pairs a function? See if we can wrap our heads around the idea of a function. So the first one, we'll just list our set of points. Now that guy is a curly bracket. That's called set notation. It is the curly bracket on your computer keyboard. It's an S and then a 2. So if you're having trouble drawing that, that's an S and then a 2. This first relation starts with negative 2, comma 2, negative 1, comma 2, 0, comma 2, 1, comma 0, and 2, comma 0. And you're going to end those curly brackets. If you're doing it backwards, that's going to be a 2 and then an S. The first thing we want to ask ourselves about this relation is to find the domain. Domain, like we said before, is the set of all possible input values. So that word set lets you know that you get to draw that curly bracket again. The set of all the input values, and just as we said, the input is that first value. So I'm going to underline those in red. We've got -2. There's the first value, and that second point is -1, 0, 1, and 2. Now domain, when we write this set, it is written in increasing order. Domain is written in increasing order. So the lowest number I see here, -2, -1, 0, 1, and 2, is -2. Next highest looks like -1. Next highest is 0, 1, and then 2. We'll close off our set. That is the domain. We'll make green our range to stay consistent. Range is the set of all output values. So set, that word again, we get to draw our curly brackets. Range is also written in increasing order. So that note applies to range as well. The range is the set of all second values, or second coordinates, the outputs. There's all of our second values, or outputs. I see 2, 2, 2, and 0, 0. So the lowest number I see there is 0. Now there are 2 zeros, but there's no need to write them twice. We just need to represent it once. We have 0 and we have 2, meaning that if I put anything into my function, I'm going to get out either a 0 or a 2. And we can close our brackets there. So we do not have to write those values twice. The next thing we need to ask, is this a function? Again, a function means that every input maps to exactly one output. So if I'm putting -2 into my function, I know that every time I'm getting out a 2. We can think about a function like a machine. If I put one thing into my machine, I want to know that every time I get a result out from that first input, I'm going to get the same thing out. So let's take a look at this function. If I put in a -2 here, I get out a 2. Are there any other places where I put in a -2 and I get something different? Nope, all of those look different, so that point is good to go. Here, if I put in a -1, I get out a 2. Is there any other instance where I put in a -1 and I get out something different? Nope, those look different to me. Notice that -1 and 1 are 2 different values. So that point is good to go. Let's check 0. If I put in a 0, I get out a 2. Every time. Looks like there's no other instance where I put in a 0 and I get out something different. So that point is good. If I put in a 1, I get out a 0. No other 1, so that one is good. And if I put in a 2, I get out a 0. So that point is good as well. So the answer is yes, this is a function. Every element in the domain maps to exactly one output in the range. So I would say yes, because each input maps to exactly one output. Let's look at another example. Part B, this is another list of ordered pairs. Here we have 4, 0, 8, 7, 6, 4, 4, 3, and 5, 2. So here's another relation. Let's see if we can answer the same questions about this relation. First, we want to list the domain. The domain is the set of all input values. So I'm looking at these first coordinates of an ordered pair. And we get to draw our bracket. I see 4, 8, 6, 4, and 5. Now this is in increasing order, so the lowest number I see is a 4. Again, I do not have to write it twice, even though there are 2 4s. The next lowest is a 5, then a 6, and an 8. So that is my domain. Let's write down the range as well. The range is the second coordinate in each point. So here I see 0, 7, 4, 3, and 2. The lowest value there is 0. That'll go first. 2, 3, 4, and 7. So that is my range. Finally, we want to ask ourselves, is this a function? Meaning, does every input map to exactly one output? Let's just go one by one. Here, if I put in a 4, I get out a 0. Is there any other instance where I put in a 4 and I get out something different? 8, 6, 4. Here, I put in a 4 and I get out a 3. Not consistent. So here, I put in a 4, I got out a 0. Over here, I put in a 4 and I got out a 3. Those are two different values, so not exactly one output. 0 and 3 are different, so this fails. This is not a function. Because the input 4 mapped to 0 and 3. And 0 and 3 are two different values, so that each input does not map to exactly one output. This is not a function. It fails because 4 maps to 0 and 4 maps to 3. Now, a list is not the only way to represent a relation. We could also do it in table form. Let's look at input and output as a table. Sometimes we call this a t-table because it starts out looking very similar to a T. You see the T there. We put the X's on the left and the Y's on the right. In this table we have -2, 3, -1, 4, 5, 0, 6, 0, 7, 1, and 8, 2. So a table